Quasars, short for quasi-stellar radio sources, are some of the most fascinating and enigmatic objects in the universe. These incredibly bright and distant celestial bodies were first discovered in the 1960s, and ever since then, they have captured the imagination of astronomers and astrophysicists alike. Quasars are powered by supermassive black holes at the centers of galaxies, which are actively accreting matter and releasing immense amounts of energy in the process. This makes quasars some of the most luminous objects in the universe, outshining entire galaxies despite their relatively small size. The study of quasars has provided valuable insights into the nature of black holes, galaxy formation, and the evolution of the universe as a whole. By observing the light emitted by quasars across different wavelengths, scientists can learn about the conditions in the early universe, the dynamics of galactic nuclei, and the physics of extreme environments. Quasars are not only important for understanding the cosmos on a grand scale, but they also serve as cosmic laboratories for testing the laws of physics under extreme conditions. In this chapter, we will explore the properties of quasars, their role in the cosmic ecosystem, and the mechanisms that drive their incredible luminosity. By delving into the mysteries of these monstrous engines of the universe, we hope to gain a deeper understanding of the fundamental processes that shape the cosmos and our place within it. Quasars, or quasi-stellar radio sources, are some of the most fascinating objects in the universe. These incredibly bright and energetic phenomena are powered by supermassive black holes at the centers of galaxies. Understanding the formation and characteristics of quasars is crucial in unraveling the mysteries of the cosmos. Quasars are believed to form when gas and dust accrete onto a supermassive black hole. As the material spirals inward, it forms a hot, dense accretion disk around the black hole. The intense gravitational forces and friction within the disk generate enormous amounts of energy, leading to the emission of radiation across the electromagnetic spectrum. This radiation can outshine an entire galaxy, making quasars some of the brightest objects in the universe. One of the defining characteristics of quasars is their redshift. This phenomenon is a result of the expansion of the universe, causing light from distant objects to stretch and shift towards longer wavelengths. By measuring the redshift of quasars, astronomers can determine their distance and study the evolution of galaxies over cosmic time. Quasars also exhibit variability in their brightness on timescales ranging from days to years. This variability provides valuable insights into the physical processes occurring near the black hole and within the accretion disk. Studying these fluctuations can help astronomers probe the dynamics of the material falling into the black hole and the mechanisms responsible for powering the quasar. In addition to their intrinsic properties, quasars play a crucial role in shaping the evolution of galaxies. The intense radiation and powerful winds generated by quasars can influence the formation of stars and regulate the growth of galaxies. By studying quasars and their impact on their surroundings, scientists can gain a deeper understanding of the interconnected processes driving the evolution of the universe. Quasars, or quasi-stellar radio sources, are among the most fascinating and powerful objects in the universe. These incredibly bright and distant celestial bodies are powered by supermassive black holes at the centers of galaxies. The role of quasars in the universe is crucial for our understanding of cosmic evolution. Quasars are not only important for studying the early universe, but also play a significant role in shaping the galaxies we see today. One of the key roles of quasars is in the process of galaxy formation and evolution. Quasars are believed to be formed when gas and dust are accreted onto a supermassive black hole, releasing an enormous amount of energy in the form of radiation. This radiation can have a profound impact on the surrounding gas and dust in the galaxy, influencing star formation rates and the overall structure of the galaxy. Furthermore, quasars are also crucial for understanding the large-scale structure of the universe. By studying the distribution and properties of quasars, astronomers can gain insights into the underlying structure of the cosmos, including the distribution of dark matter and the expansion of the universe. Quasars serve as beacons that illuminate the cosmic web, helping us map out the vast network of galaxies and galaxy clusters that make up the universe. In addition, quasars are important for testing the fundamental laws of physics. The extreme conditions near supermassive black holes allow scientists to study the behavior of matter and energy in ways that are impossible to replicate on Earth. By observing the properties of quasars, researchers can test theories of general relativity, quantum mechanics, and the nature of dark matter and dark energy. Overall, quasars play a multifaceted and essential role in our understanding of the universe, from the early stages of cosmic evolution to the fundamental laws of physics. Studying these monstrous engines of the universe is key to unlocking the mysteries of the cosmos. Active galactic nuclei, AGN, are the incredibly powerful and energetic regions at the centers of galaxies. These nuclei are fueled by supermassive black holes, which can be millions or even billions of times more massive than our Sun. The intense gravitational forces around these black holes cause the surrounding gas and dust to heat up and emit enormous amounts of radiation across the electromagnetic spectrum. This radiation can outshine the entire galaxy in which the AGN resides. There are several types of AGN, each with its own unique characteristics. One common type is known as a Seyfert galaxy, which has a relatively low level of activity compared to other AGN. Another type is a radio galaxy, which emits powerful jets of radio waves extending far beyond the galaxy itself. Quasars are another type of AGN, characterized by their extreme luminosity and high redshifts, indicating that they are located at vast distances from Earth. Blazars are a subcategory of quasars that appear to emit jets of radiation directly towards Earth, making them particularly bright and variable sources of light. Understanding the different types of AGN is crucial for studying the evolution of galaxies and the role of black holes in shaping the universe. By observing and analyzing these monstrous engines of the universe, scientists can gain valuable insights into the physics of extreme environments and the processes that drive the growth and evolution of galaxies. Active galactic nuclei, AGN, are some of the most energetic and luminous objects in the universe, powered by the accretion of material onto supermassive black holes at the centers of galaxies. The emission mechanisms in AGN are complex and involve a variety of physical processes. One of the key mechanisms responsible for the emission of radiation in AGN is the accretion disk around the central black hole. As material spirals in towards the black hole, it forms a hot, dense disk that emits radiation across the electromagnetic spectrum. This radiation can be observed from radio to gamma-ray wavelengths. Another important emission mechanism in AGN is the relativistic jets that are launched from the vicinity of the black hole. These jets can extend over vast distances and emit radiation through processes such as synchrotron and inverse Compton scattering. The interaction between the jets and the surrounding interstellar medium can also lead to the emission of radiation in the form of shocks and hotspots. In addition to these mechanisms, AGN can also exhibit variability in their emission, with fluctuations in brightness occurring on timescales ranging from minutes to years. Understanding the emission mechanisms in AGN is crucial for deciphering the physics of these extreme objects and their impact on the evolution of galaxies and the universe as a whole. Quasars and active galactic nuclei are not just fascinating objects in the universe, but they also have profound implications for our understanding of the cosmos. These monstrous engines of the universe provide valuable insights into the most extreme conditions in the universe, helping us unravel the mysteries of black holes, galaxy formation, and the evolution of the universe itself. By studying quasars and AGNs, we can probe the physics of accretion disks, relativistic jets, and supermassive black holes, which are crucial components of these enigmatic objects. The high energies and luminosities emitted by quasars and AGNs allow us to study the effects of gravity, magnetic fields, and radiation in ways that are not possible with other astronomical sources. Furthermore, the discovery of supermassive black holes at the centers of galaxies, which are believed to power quasars and AGNs, has revolutionized our understanding of galaxy evolution. These black holes are thought to play a key role in regulating the growth of galaxies by influencing the formation of stars and the dynamics of gas within galaxies. Additionally, Quasars and AGNs serve as cosmic beacons that can be used to trace the large-scale structure of the universe and study the distribution of matter on the largest scales. By observing the light emitted by quasars and AGNs, astronomers can map out the cosmic web of filaments and voids that make up the cosmic web, providing valuable information about the underlying structure of the universe. In conclusion, the study of quasars and AGNs has far-reaching implications for our understanding of the universe, from the smallest scales of black hole physics to the largest scales of cosmic structure. These monstrous engines of the universe continue to captivate scientists and inspire new discoveries that push the boundaries of our knowledge of the cosmos.